The last thing that we're going to do is we're going to actually graph some of these equations. Okay, so again, in the last lesson we managed to figure out how to graph shape and vertical shifts, but now we're going to start to incorporate horizontal shifts, so changes in the h value. So we talked a little bit about the step pattern, that over-up pattern where you go over 1, up 1, over 2, up 4, over 3, up 9, all relative to the vertex. And so we're going to extend that knowledge a little bit as we go through. So let's take a look here. We've got 4 to begin with and then a few more on the next page. But in our first example, we've got y is equal to x squared. And y equals x squared is, again, the parent form of all of our parabolas. We know that the origin of that is at 0, 0. Okay, and then using our step pattern of over 1, up 1, we can actually quickly just plot in kind of our baseline thing, parabola that we're comparing all of the other parabolas to. Okay, so there's our baseline parabola. Now if we take a look at the next example over to the right, it says y is equal to x minus 1 squared. Okay, well, we know that there's now been a change in the h value. In this case, the h value is actually positive 1. So what this means now is that the vertex has been shifted 1 unit to the right. So now instead of having a vertex at 0, 0, our new vertex is at 1, 0. Okay, but now our step pattern still applies because there's no change to the a value at all. A is still positive 1. So we still go over 1, up 1, over 2 from the vertex, up 2, over 3 from the vertex, up 9. Okay, so all we did was we shifted this parabola to the right by 1 unit. So the shape of it hasn't changed at all, it remains the same. If we look at the next example, here we've got y is equal to 2x squared. Okay, so again, if we look at the a value is positive 2, the h value is 0, and the k value is 0. So we know that this particular parabola is going to still have a vertex of 0, 0. Okay, it's not shifted to the right or to the left because the h value is 0, and it's not shifted up or down because the k value is 0. However, the a value is now positive 2, and that means that our step pattern of 1, 4, 9 is going to change. So if we look at our basic step pattern of 1, 4, 9, sorry, if we look at our basic step pattern where we go over 1, over 2, and then over 3, we went 1, 4, 9. Okay, that's the original parent form of the parabola. But because the a value has changed, we need to multiply the y values of the parent form with the a value. So y2, again, is equal to y1 times the a value. So in this case, y1, this is y1 here, so 1 times 2 is 2. 4 times 2 is 8. 9 times 2 is 18. So now instead of going over 1, up 1, over 2, up 4, over 3, up 9, we're going to be going over 1, up 2, over 2, up 8, over 3, up 18. Okay, so if we go over 1, up 2, again, that applies to both the right and the left-hand side. Over 2, up 8. Okay, and so you can see how this parabola is significantly skinnier, and I can't even do the over 3 because there's not enough height on my graph. Okay, so up like so. If we look at the next example here on the right, we've got y is equal to negative 2x squared. Okay, so our a value is actually negative 2, our h value is still 0, and our k value is still 0. So our vertex hasn't changed. Our vertex remains at 0, 0. What has changed is the direction of opening. Okay, so now instead of going up to, over 1 up to, now we're going to be going over 1 down to. Okay, so we still have um, our same pattern, okay, our same step pattern, but now instead of multiplying y1 by positive 2, now we're multiplying y2 by negative 2. So 1 times negative 2 is negative 2. 4 times negative 2 is negative 8. 9 times negative 2 is negative 18. So what ends up happening is that this parabola is actually going to be facing or opening up downward. Okay, and so we can draw in our graph going downward. Okay, so it is the exact same shape as the parabola to the left, but in this case it is opening downward. We'll continue on. We've got a parabola here that's y is equal to x plus 4 all squared. Okay, so our a value is still positive 1. Our h value in this case is actually negative 4. And our k value remains 0. So now what we have is we actually have a horizontal shift. Since the h value is equal to negative 4, that means that it is being shifted 4 units to the left of the vertex. And because our k value is 0, it remains on the line. So our k value, our vertex is at negative 4, 0. But because the a value is positive 1, our step pattern will still apply. It still goes over 1, up 1, over 2, up 4, over 3, up 9. Okay. So the a value always determines the shape and the direction of opening. The h value always determines the horizontal position. The k value determines the vertical position. If we look at the next example here on the right, we've got x squared plus 4. So the a value is plus 1. The h value is actually 0. There is no h value. Okay? And the k value is actually positive 4. Okay, so in this case, there's no horizontal shift to the right or to the left, but because the k value is plus 4, it's going to move that vertex up 4 from its original location. And then because the a value is plus 1, it opens up. And because it's 1, there's no change in the shape of the parabola. So our original step pattern applies. So over 1, up 1, over 2, up 3. Okay, and then we can extend it up. If we look at the last two examples, it becomes a little bit more complicated, but it's still relatively straightforward. We will again identify our AHK values. Our A value is positive 3, so it's going to open up. We know that there's going to be a vertical stretch because the A value is bigger than 1. The H value is positive 2, okay, and the K value, well, there is no K value, okay. So let's first plot where the vertex is. The vertex is going to be at positive 2, 0. Okay, but because the A value is different, we're going to actually have to make some calculations quickly about the shape of this particular parabola. So because the A value is not positive 1, that means that the shape is going to change. So again, if we look at our x, y1, y2 values, so we'll go 1, 2, 3 is usually good enough. In the original step pattern, it goes 1, 4, 9. And again, y2 is always equal to y1 times the a value. So our a value is positive 3. So 1 times 3 is 3. 3 times 4 is 12. 9 times 3 is 27. Okay, so we're going to use the pattern over 1 up 3, over 2 up 12, over 3 up 27. So over 1 up 3, over 2 up 12, okay, so it's going to be significantly compressed. Okay, or sorry, not compressed, significantly stretched. And then finally, the last example that we have here, we've got an A value that is -4. We've got an H value that is -1, and a K value that is 0. Okay, so because the H value is -1, we can plot where the vertex is going to be. It's going to be at -1, 0. And again, similarly, because the A value is not +1, in this case, it's actually a negative number, so it's going to be going down. But we will also plot in our step chart, okay, or a step pattern. So X, Y1, Y2. So 1, 2, 3, 4, 9. Because our new A value is -4, remember Y2 is always equal to Y1 times the A value. Well, the A value is -4. Y1 is 1, so 1 times -4, -4. 4 times -4, -16. 9 times -4, -36. Okay, so in this instance, we know that it's going to be going over 1, down 4 units. Then it'll go over 2 from the vertex, down 16 units. So it's going to go quite far down. Okay, so maybe something on the order of this. Okay, so it's significantly stretched. So that is how you take an equation and you manage to create a graph from it.